Greetings and welcome, friends. Mr. Waddy here. Today we are talking about special parallelograms and like properties of them and such. And we are going to look at some special parallelograms. You've probably known about these shapes before. They do exist. But here we go. It says in this lesson you'll learn about 3 special types of parallelograms. That means all of these are parallelograms? Yeah? Yeah, that is what that seems to suggest, and they are, in fact, all parallelograms. That means all of the properties of parallelogramness apply to these 3 shapes, these 4-sided figures that are subsets of parallelograms. All of those properties apply, but these also have special circumstances for them. So the first thing is rhombus. A rhombus is a parallelogram with 4 congruent sides. All right, so rhombus, call it a diamond, it is still a type of parallelogram. A rectangle, by definition, is a parallelogram with 4 right angles. And now check this out. A square is a parallelogram with 4 congruent sides, which means, what was 4 congruent sides a moment ago? That means it's part rhombus, or it has the attributes of a rhombus, and 4 right angles, right? So that also has the attributes of a rectangle. There we go. And that's why I've argued that a square should be called a rhombangle, which is just such a cool name, or a rectombus. Right? So I don't know. I think either of those would be good names for a square because it happens to be both of those shapes simultaneously. All right, so these are some interesting parallelograms. So here we go. Here's some corollaries for us. Ooh, because these are subsets of parallelograms. They've got some additional properties. Like, here we go. The rhombus corollary. A quadrilateral is a rhombus if and only if it has 4 congruent sides. All right, there you go. That's kind of like just the definition of a rhombus, it feels. A corollary is a short step after a theorem. It practically would have been a postulate. So a square is a type of rhombus, but not all rhombuses are squares. All rhombi? Rhombi? Yeah, I don't know. So yeah, this is a rhombus because all 4 of its quadrilateralness sides are congruent. Rectangle corollary. A quadrilateral is a rectangle if and only if it has 4 right angles. All right, and the if and only if language means that these are biconditional statements, so they're also true in reverse. So if I say this is a rectangle, then you can say then it has 4 right angles. If I say here's a quadrilateral with 4 right angles, you could say then it is a rectangle. All right, and let's see. I bet you guys can guess the next corollary. Oh, what? The square corollary? Man, you guys should have invented or discovered math and then named it because you're so good. You're so good at the... Oh, you guys read it off? You guys should be known for your literacy because you were able to read that off the paper I gave you. There we go. Square corollary. A quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay, both of those at the same time. Good old squares. We love you. Guys, check this out. I love this sketch. I love this. You guys remember Venn diagrams? Actually, who is it? Is it Jimmy Fallon? I think he's got Venn diagrams on his show sometimes. Who is it? Or was that Seth Meyer? That might have been a Seth Meyer thing. But here we go. This is a Venn diagram of types of parallelograms. Technically, Josh, when you're quiet, we could also say that all of these parallelograms are within their own box of quadrilaterals, and quadrilaterals are within their own category of polygons. All right? So here we go. Imagine the world of parallelograms. All right? So that's this large rectangle, oddly enough. Right, so parallelograms, by definition, opposite sides are parallel. Within parallelograms is a subset of those that are referred to as rhombuses. All right, so that's this oval over here. Rhombuses have 4 sides congruent. So you got some like this, or that, or this. And then we also have some parallelograms that are rectangular, that they've got 4 angles that are congruent. And notice the squares are the overlap between both rhombuses and rectangles. Right? So there we've got this lovely little sketch that kind of shows the relationship between all of those things. All right, so let's do an example for once. Here we go. Example. Always, sometimes, or never. Man, this makes, like, do these make you nervous? Like, you feel like you have to commit to one of these words? Actually, this doesn't even have never. They didn't give us that option. It's just always or sometimes. So, for any rhombus, okay, so they've given us some very narrow description. Decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. All right, so QRST. So QRST. So QRST. So here's a rhombus. By definition, if it's a rhombus, I know that these are congruent to each other. They're asking me, Isaiah, will angle Q be congruent to angle S always or sometimes? Always. Why are you thinking always? A rhombus is a type of parallelogram. Yeah. Parallelogram, opposite angles, congruent theorem. Something like that. Yeah, that sounds good. All right, I like it. How about this one? Angle Q in that same sketch, congruent to angle R. How often does this happen? Always, or if these two are congruent, it would be what type of shape, Anthony? For squares, it's true that the adjacent angles would be congruent, or the consecutive angles would be congruent. What about non-squares? Then it won't be for non-squares, so I think the answer is sometimes. And that sometimes occurs when the time is square time. It's square time. All right, here we go. Un otro ejemplo. Ejemplo dos. All right, here we go. Classify the special quadrilateral. I just want to let you guys know you're all so special. In case you didn't know that. So here we go. Classify the quadrilateral. So this is a quadrilateral. Is it a parallelogram? Is it a para? Yes. Because why? Right. Opposite sides are congruent, so parallelogram, opposite sides congruent theorem. Okay, so it's a parallelogram. Of the parallelograms, what special type do you think it is? I think it's in the rhombus category. I think I would agree. Rhombusness seems to be maximized here. You guys agree? You seeing that? Why is it a rhombus? Because of the rhombus corollary. Actually, I need a little bit more than that. I'll call it the Rom corollary, Rom-C. Well, because there's also like a rectangle corollary. Yeah, so an abbreviation is only helpful if it still maintains its specificity. Yeah, like when I memorize people's names by first initial, that breaks down really quick once there's more than like one person with the same first initial. Yeah, just doesn't work. Okay, here we go. Here we go. Oh, some more theorems coming at y'all here. All right. Isaiah, you with us? I feel like you're distracted today. Yeah. And today is day 52 of our course, internet friends. Of 88 for this semester. Next semester has a little bit more time. Wow. I don't know. I'll have to check. The rhombus diagonal theorem. Guys, check this out. Shh. Amigos. Right? Gentlemen, in the back, on the side. Yeah. A rhombus diagonal theorem. A parallelogram is a rhombus if and only if its diagonals are what? Perpendicular? Wait a minute. Okay. Wait a minute. I know I'm trying to count out to a minute until it's square time. Its diagonals are perpendicular? It's an if and only if? Guys, what? What? Now for parallelograms, what was true about their diagonals? If we broaden the category. They bisect each other for all parallelograms. This is saying if they're perpendicular to one another. I'm trying to think, is there a way I could quickly do this? Let's see. All right, let me see if I can do this. Let me open up a new sketch. Okay, so for a rhombus, all right, I'd have. Do you guys know how could I construct a rhombus? Here, I'll construct a circle at this as its center with the same radius as that. All right, and I'll do the same thing for this center and that radius. And the intersection between these two. Do you guys feel like this is a rhombus? Mm-hmm. Yeah, because all of those are radii of congruent circles. Let's hide those circles here. So yeah, so no matter how I... Whoa, look at it move. That's so crazy. Whoa, it broke there a little bit, but... All right, there we go. Yeah, it's just the way I defined it. Well, anyways, so that's a rhombus. Let's draw some diagonals, friends. How could I measure perpendicularity in a sketch like this? For perpendicularity, I could measure the slopes. Now check this out. Let's see, in case you don't realize this, let's calculate this. I'll do 1 divided by that, and I'll opposite it. Because what did I do there? That's the opposite reciprocal. And what can you tell me about opposite reciprocals? Lines that have slopes that are opposite reciprocals are perpendicular to one another. So yeah, so it appears as though all of these rhombuses I draw have slopes that are opposite reciprocals of each other. Let's see. All right, wow. All right, I feel like that makes sense. It sounds like you might end up proving this. Well, maybe we'll do it together someday. Rhombus opposite angles theorem. The rote. Rote. Now that just makes me think of, like, what was that? Croton? What is that? What was the name of that town where everyone disappeared? Roanoke. That one probably too. It says the parallelogram is a rhombus. So yeah, maybe they were trying to, like, what if Croton found, like, carved into the tree, they were trying to, like, refer to some rhombus fact? I don't know. We'll have to figure that out. Mystery solved, though. We're close. Parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Wow. So, wow. Yeah, you can go look that up someday. No one knows. No one living knows, anyway. Okay, let's do example 3 for sake of time. All right, here we go. Example 3. All right, find the measures of the numbered angles. I love it. Guys, how about measure of angle 1? What's that going to be? It says this is a rhombus. 90. Man, Josh, with the swiftness. 90. Bam. Okay. What else do I got? Measure of angle 2. let's see. Well, a rhombus is a type of parallelogram. Those are alternate interior angles, so that's 61 degrees. Actually, what was the theorem that we just had for the 90s? Rhombus, diagonals bisect, or perpendicularity. The 90s theorem? Rhombus diagonals theorem. Right, Lauren? RDT, rhombus diagonals theorem, is why that's true. These are both 61 by alternate interior angles theorem. Okay. How about 3 and 2? Those are the same. Why? Because rhombus, what was it? Wrote, right? Wasn't it wrote? But I already forget what it stood for. Opposite angles theorem? Bisect a pair of opposite angles. Okay. Opposite angles theorem. Wrote. And then, how am I ever going to find angle 4? Huh. Well, I know that this angle, well, third angle theorem's the easiest, but I also know that this entire angle would be supplementary with that entire angle, right? Yeah, I'm going to say the third angle theorem, tat, 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 right? And so, yeah, 90 minus 61, or that was like a corollary of the third angles theorem. Well, right? 90 minus 61, you're saying 29? All right, I believe you. I believe you. All right, here we go. Wow, guys, another theorem. Wow, lots of special, what a special day. Like special parallelograms, we got properties of these things, we got theorems about them. The rectangle diagonals theorem. A parallelogram is a rectangle if and only if, bless you, its diagonals are congruent. Now, I already know that all parallelograms have diagonals that bisect each other. But here we're saying, let's see, did I still have that other window open? Let me redraw this. Let's hide those. Let's draw these diagonals. So this is claiming that for rectangles, which actually I haven't even proven to you that this sketch was a rectangle yet, that its diagonals will always be congruent. Lengths, there we go. And so let's see, what? Okay. All right. I'm seeing that. Now, like I said, we still technically haven't proven that this is a rectangle, but it is. But yeah, there you go. So the diagonals not only bisect each other like they do for all parallelograms, but the diagonals are congruent to one another for rectangles. So let's put these to the work. Here we go. Identify a rectangle. All right, example 4. You are building the frame for a window. All right. I'm imagine this. Oh wow, this is actually, yeah. I'm seeing this too. Bring me a dream. So let's see. You are building the frame of a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? I mean, you can assume anything. They want us to explain it. Well, I've got opposite sides are congruent. So, can I assume this is a rectangle yet? No. No. I know that it's a parallelogram. Right, Aiden over there? Right, it is a parallelo. But I don't know it's a rectangle, which is why when you're framing out walls, when you're building the rooms of a house, just because the opposite walls are equal in length to each other does not mean you've built a rectangular room. It does not mean that those walls meet each other at a 90-degree angle, right, Anthony? says you measure the diagonals of the opening. Aha, diagonals, right? So if you measure these, and this is something that I did back in the days of construction with someone who was not an official geometrician. They were just my boss who'd be like, hey, let's measure the diagonals of this. And it says these diagonals are both 54.8 and 55.3. Do you guys think it's a rectangle? Well, by the rectangle diagonal theorem, it is not rectangular. Because the diagonals are not congruent. And so what you can do when your diagonals are not congruent, diagonals are not congruent. You can actually, in this case, it looks like they've locked themselves in pretty well with all of the framing they've done. But in the case of if you've framed out some walls and you're about to tack them together, you can just shift the walls, which you know are a parallelogram, until the diagonals will become a congruent. So this, if you're ever doing construction and you want to quickly determine that, the way to do it, friends. The way to do it. All right, last question maybe? Yeah, oh, I should get to that one too, though. Man, this is a rough day. How are you guys doing, though? You guys doing okay? We had the long weekend, at least. Coming in pumped for geometry. All right, finding diagonal lengths in this rectangle, blah, blah. Find the lengths of the diagonals. What could I do? Well, I know that these two diagonals are going to be congruent to each other, and therefore 5x minus 31, it's the same as it always is, friends. Same idea. You guys are algebra experts, algebraticians. 3x minus 31 equals 11. Man, I'm getting sleepy, though. Took a nap in my hammock in my basement yesterday, right above my pellet stove. Yeah, it was amazing. Yeah, I used little bicycle J-hooks like this and like screwed them into the beams of my house so then I can quickly like just fast set up my hammock between them. Yeah, it looked kind of like that, yeah. Like when SpongeBob and Patrick were playing hooky. Wow. All right. 4 plus 10, 14. Wow, okay. X equals 14. So what are the lengths of the diagonals, though? So let's find RT, because those are smaller numbers. So that's going to be 2 times 14 plus 11. So 28 plus 11. That's 39. So both diagonals, RT and QS, are going to be 39 units long. Because they told me it's a rectangle. But yeah, hammock in my basement. That's the way to live. Alright. Truly the last example now. I know. You guys are like, oh, come on. Maybe you guys tell me how I would do this problem. Let's not even do it out. Just tell me how I would do it. Decide whether this shape right here is parallelogram, not just a quadrilateral. So I already know this. What can I do, though? Don't pack up. Guys, even if we're done this problem, we still got 3 minutes, so. How could I determine whether it's a rectangle? What could I do, though? Find slopes and check for perpendicular, right? That's one way. Yeah. Aiden, what was your solution? You said midpoints. Well, what about distance formula? How could I use distance formula? Distance formula of diagonals, right? And check if equal. Wait, hey, sit down. Sit down, friends. Do not pack up. I'll keep you all 2 minutes late if you start packing up 2 minutes early. It's only 2 minutes. Come on. How about rhombus? How could I check for rhombusness? We could do 4 distance formulas. Distance formula for sides. What's another way I could do it? Angie's list. You guys would pay me to do math for you? Let's see, yeah. Opposite sides congruent, so that's by definition. How about diagonals? Find slopes of diagonals. Right, and what would I expect? Check for perpendicularity, right? So their slopes would be opposite reciprocals of one another. Let's see. And how could I check for squareness? It needs to pass both the first 2 tests, right? Yeah. Both tests. Yeah. Here we go. So without having had to do it all out, I just want to point out that's some of the ways that we could make that happen. Thanks for watching, internet friends.